Our natural resources are finite, yet most people give them little thought in their daily lives. They trust that the water will come out of the tap and the air they breathe is free of pollution. The President's Action Plan on Climate Change notes some compelling statistics. The weather is getting more extreme across the nation. 2012 was the second most extreme year on record, and this extreme weather comes at a very high cost. Climate and weather disasters in 2012 cost the American economy more than $100 billion. These are costs associated with drought, extreme flooding, hurricanes, wildland fire, and severe weather. Our population will continue to grow, and that will affect our natural resources like water and air quality. What is the projected outlook for Arizona? Are we doing enough to prepare for those changes that await us? Our goal is to discuss what we need to know and what needs to happen as air quality changes, water levels ebb and flow, and our resources become more strapped.
Arizona is an arid region where more water evaporates every year than falls as either rain or snow. Compounded by its complex topography, the state experiences a wide variation in its temperature and precipitation patterns, including extreme events. Even in this desert state, extreme events like winter storms bring snow to the high country that allow for storage of desperately needed water. Sometimes, however, these storms become blizzards that last several days without a break, piling heavy wet snow on highways. In January 2010, a 5-day snowstorm dropped 54 inches of snow in Flagstaff in northern Arizona, shutting down Interstates 40 and 17, stranding motorists on the highways and isolating thousands of local residents. Will we see more of this in the future? As in the past, a blizzard of that intensity and duration is unlikely to occur every year, but we do expect a higher frequency of intense storms in the future, as Arizona's weather will continue to be defined by extremes of wet and dry, hot and cold. Warmer temperatures will increase the likelihood of rain versus snow events. In 1980, after significant snowfall in the Salt River watershed during the early winter months, a warm storm crossed the state, dropping 10 inches of rain on the snowpack, resulting in rapid snowmelt and runoff headed for Roosevelt Lake. At the time, the reservoir level was already quite high, and dam operators had to start releasing water as quickly as possible to make space for the runoff. The flooding through the Phoenix area closed all but 3 bridges in the valley and changed the way we view the Salt River Channel. Warmer temperatures have moved the path of the jet stream further north, sending the average storm tracks further north as well. The lack of cold winter storms has reduced the winter snowpack at the higher elevations, thus reducing the spring runoff that we depend on to fill our reservoirs and recharge the groundwater aquifers. While heavy winter storms represent significant short-term emergencies, drought is a slow-developing long-term disaster. In the western United States, drought is characterized by a pattern of drier than normal years that accumulate a moisture deficit. Earlier than normal snowmelt reduces the amount of water that reaches the reservoirs and stream beds. For forests, this results in stress on the trees, reducing their ability to fight off insects and disease, and increasing their susceptibility to large-scale wildfires like Rodeo Chetasky in 2002. That fire burned more acreage than any fire in Arizona's recorded history, until the Wallow Fire in 2011. Could that magnitude of a wildfire happen again? Yes, from a climate viewpoint, it absolutely could, if the current drought continues or intensifies, or during a future drought. And even the smaller fires can be catastrophic with loss of life. So what's the outlook for drought? According to the National Climate Assessment for the Southwest, Arizona's snowpack is projected to decrease by almost 50% by 2050. Will the snow be replaced by rain? Probably, but winter rainfall with warmer temperatures will reduce the runoff, resulting in lower reservoir levels. The historical record shows mega droughts in our past, and they are likely to appear in our future as well. But when the heavy precipitation falls on a wildfire burn scar, there is little vegetation to slow the water, and large amounts of sediment and ash are transported downstream, clogging washes and stream beds, creating significant flooding. Most of our precipitation falls at higher elevations and flows downhill in steep canyons and washes, resulting in flash flooding. The floodwaters can cause enormous damage to the stream beds, roadways, culverts, and bridges. as well as potential loss of life to individuals caught up in the rapidly rising waters. In July 2006, the Tucson area received 5 consecutive days of heavy rainfall, setting new record rainfall totals in the Catalina Mountains, leading to flooding, slope failures, and debris flows. Will the future be wetter or drier? With warmer ocean waters in the eastern Pacific Ocean, there's more moisture in the atmosphere to bring heavier rain or snowfall. When the tropical moisture is drawn into the monsoon flow, flooding of historic proportions is possible. Phoenix had 3 events of this magnitude in 2014. Will the future be warmer or cooler? Extreme heat is another hazard that is particularly deadly in Arizona, but the danger is not limited to the southwest deserts. Most locations in the high country do not currently experience 100-degree or warmer temperatures, and many residents do not have air conditioning. As temperatures across the state climb, the number of people at risk from heat increases. The low elevations are already deadly for summer heat, with an annual average of 160 heat-related deaths since 2003, primarily affecting outdoor workers, recreationalists, the elderly, and the poor who do not have access to air conditioning for a variety of reasons. Global climate models project average summer and winter temperatures to increase by 7 to 8 degrees by the end of the century. Some of this heat is already here in the Phoenix area, so we need to begin mitigation now. Faced with this multitude of impacts from extreme conditions, what are we doing to prepare? An ongoing Arizona State University research project is targeted at emergency managers to help build capacity and prepare for handling these extreme events. Preliminary findings of this research, funded by FEMA, NOAA, and DEMA, suggest that if emergency planners receive relevant, actionable climate information for their jurisdiction, they will be better positioned to implement effective mitigation actions to reduce the impacts of these future events. As future conditions continue to change, our whole community, including planners, have to continue finding ways to keep the growing population of Arizona safe and resilient. Better communication about the probability and magnitude of extreme weather events and their impacts will empower planners and the public to take appropriate actions. While we can't prevent extreme events from occurring, we must take all reasonable steps to reduce or eliminate the impacts on both our infrastructure and our ability to provide necessary services to the whole community.